Okay, so this is the fourth part. It's the final part of factorization. Um, I have copied the rules onto this page so that we can keep referring back to them. Let's try and finish up this exercise. All right, so question 6 says x to the power of 6 minus 81. First rule says look for a common factor. Is there one? Nope. Second rule, count the terms. There are two terms, which means this could possibly be squares or cubes. It looks like it's a difference. There are two terms, they're both squares. So this is going to be a difference of two squares. Open up two brackets with a plus and a minus. The square root of x to the 6 is x to the 3 and x to the 3. The square root of 81 is 9 and 9. Check in your brackets. Can you find another difference of squares? No, x cubed is not a square. Is there maybe a difference of cubes? No, because 9's not a cube either. So this is as far as this sum can go. Question 7. X to the power of 7 minus xy squared. First rule, common factor. Is there one? No. Sorry. Did I say that? I wasn't concentrating. Okay. First rule, common factor. Is there one? Yes. X. Take it out. Leaves me with an x to the 6 minus y squared. Look at what's left in your bracket. There are two terms, which means it either is going to be squares or cubes. This is a difference. There are two terms. They're both squared. So I'm going to open up two brackets with a plus and a minus. X cubed, y and y. Right. Question 8. X squared minus a squared plus 6xy plus 9y squared. All right. First rule, common factor. Is there one? No. Second rule, count the terms. There are four terms, which makes it a grouping sum. First rule of grouping, look for a trinomial. Can you see one? X squared plus 6xy plus 9y squared. So let's write it in the correct order. X squared plus 6xy plus 9y squared minus a squared. Split it down the middle. Well, not down the middle, after the trinomial. The factors of 9 to give you a 6 are going to be 3 and 3. To get a positive 6, we need a plus and a plus. So that gives you an x plus 3y and an x plus 3y. And a minus a squared. Now we're starting all over again. First rule, common factor. Is there one? No, because there isn't a bracket in my second term. Second rule, count the terms. There are two terms, which means this could possibly be a difference of two squares. So we're going to open up two brackets with a plus and a minus. X plus 3y in both first positions and a in both second positions. Got it? I'm working a little bit faster now so that you can get into the rhythm of how these things should be working, how fast they should be working. All right, 4p to the power of 4 plus 3p squared minus 1. First rule, common factor. Is there one? No. Second rule, count the terms. There are 3 terms, which makes this a trinomial. Does that look like a trinomial to you? Might look a little bit weird. But think to yourself that this guy over here is really like saying 2p squared all squared. Make sense? So p to the 4 is like p squared squared. So yes, there are twice as many here as there are there. And yes, that is therefore going to be a trinomial. It's a trinomial in which the first position will have a p squared in instead of an x, right? So, what kind of a trinomial is this? It's a difficult trinomial. So we're going to take the factors of 4 and the factors of 1. Factors of 4 are 1 and 4, 2 and 2. Factors of 1 are 1 and 1 to give you an answer of positive 3. Take those that are closest together. 2 and 2 won't work. Cross it over. 2 and 2 still won't work. So we can't use these factors. We move on to the next option. 1 times 1 is 1. 4 times 1 is 4. 4 and 1 will work to give me 3. So now I write it down like a baby. 1 times 1 is 1. 4 times 1 is 4. I'm looking for a positive 3, which makes it a plus and a minus. Plus and minus, and put the sausage in. Just beware now. You're not going to put an x anymore. You're going to put a p squared, right? We decided that's what comes in the first position. So these two now automatically become a p squared. This gives me 4p squared minus 1 and p squared plus 1. Check to see if you can go further. Here I've got 2 terms. 2 terms could be squares or cubes. This is a difference. There are 2 terms. They're both squared. So this bracket on its own can go further. It's going to give us a 2p plus 1, 2p minus 1. Got it? But now what about this guy? Can he go further? Nope, because he's a plus. So this is not a difference of squares. It's just a plus of 2 squares. So we're going to keep this as a p squared plus 1. No change. And I'm going to do one last question with you guys. And then I'll leave the rest of the exercise for you to do independently. Number 10. 3b squared minus 15b minus 252. First rule, common factor. Is there one? Nope. Wait, no. I lied. There is one. You can take a 3 out. That leaves you with a b squared minus 5b minus 84. Big number, but it's the right number. This is now an easy trinomial. So we're going to take the factors of the last guy, 1 and 84, 2 and 42, 3 and 3 goes in there twice, 8, 3 and 28, 4 and 21, 5 doesn't go, 6 does go, 6 and 14, 7 doesn't go, 8 doesn't go, 9, oh wait, hold on, 7 does go. What am I talking about? 7 goes in how many times? 12, right? And then we found our pair. We want to get a negative 5, so it has to be a negative 12, positive 7, which gives you 3b plus 7, b minus 12. Done. So, bottom line, This is probably one of the most important foundation chapters that exists in maths. If you cannot factorize, it is a process that you're going to use so often that you cannot afford to have this chapter keep you behind. So make sure you are proficient in it. Practice, practice, and practice again, and practice 10 times over. Okay? Remember that factoring is the opposite of simplifying. So we will be creating brackets, not getting rid of the brackets. There are 5 types of factorizing, but really you need to know how to do the jumbled up mixed examples. These are the ones that you're going to be using in your other equations and expressions and fractions. Okay? Learn the rules. The rules are foolproof. Make sure you can do the sausage sums. They look like more work because we do a lot of calculation type stuff over here, but really most people are visual. So if you write things down, you can think faster than if you're trying to do it in your head. Okay? Good luck. And let me know if you've got any questions. Bye.